In this video, we're going to talk about how to describe transformations on the log function. So remember that logarithmic functions have the form f of x equals a log base b of x. So let's look at the function f of x equals the log of x, where b is 10, to study the effects of transformations. So remember, there are three types of transformations. We have shifts, which are translations, stretches or compressions, and reflections. We'll use these notes as a guide to help us as we look through some examples of how the values of a, b, h, and k affect transformations of the logarithmic function. So let's describe how g of x differs from f of x. So f of x is the natural log of x, so that's the parent function. And then we want to think about how negative natural log of x plus 2 is going to be transformed from that function. So notice the changes we have. We have the negative in front, and we also have this plus 2. So that negative in front, that's going to be telling us that the value of a is less than 0, right? So a is less than 0, so that means we have a reflection over the x-axis, right? Because that's what the study guide tells us. And then also we have that plus 2. Well, if we have a plus 2 on the inside, we have one of those x plus 2 situations. So that's going to be a shift left 2. Okay, and you can see where I'm getting this information from is right here in the study guide. We have x plus h, and we also have a reflection over the x-axis. Let's go ahead and go to Desmos and make sure that our description does match what's happening with the graph. So we have negative natural log of x plus 2. And you can see that, in fact, this graph is reflected from the parent function, and it's also shifted to the left 2 units. So now you can go ahead and pause the video and try describing this transformation on your own. So here we have the parent function, which is log of x. It's transformed to 3 log of x plus 2. So if we look at Desmos and we compare it with the parent function, you can see that this has been vertically stretched, and also it is shifted to the left. Okay, so that's the transformations we see from the equation. So now let's try this example. The function f of x equals a log base 3 of x is vertically stretched by a factor of 3 and shifted left 4 units to form g of x. So let's see what's going on here. So vertically stretched by a factor of 3, a vertical stretch means the absolute value of a is greater than 1. So in this description, it's telling us something about the value of a. Shifted left 4 units means that we have an x plus h sort of situation going on here. So we have x plus h. And so if we go ahead and decide what this looks like, that's going to be a is 3, and then our x plus h is going to look like x plus 4. So let's go ahead and write this new transformed function. We're going to start off with the parent function, which is the log base 3 of x. But instead of x, we're going to put that x plus 4 here in parentheses, and then that a needs to go in front. Okay, so we have 3 times the log base 3 of x plus 4. So we can go ahead and graph this in Desmos. Remember to do logarithms of a base other than the natural log or the log common log. We need to go down here and choose log base a. The base, I'm going to enter 3, and then I'm going to type x for the parent function. And then for the transformed function, I'm going to go back. Once again, I'm going to choose the log base a and then do 3. And then on the inside, I'm going to do x plus 4 and then close the parentheses. And remember, in front, I need that 3 that reflects the value of a. You can see here this graph is in fact vertically stretched, and it's also shifted to the left 4 units. So now you can go ahead and pause the video and try doing this example on your own. So here it says the log base 3 of x is vertically compressed by a factor of 1/2 and shifted down 5 units to form g of x. Write the equation of the resulting function. So we have our parent function log base 3 of x. Vertically compressed by 1/2 means that we have a 1/2 for our value of a, and then shifted down 5 units means we need a 5 on the outside of the logarithm. Okay, so this parentheses closes with x, and that minus 5 goes on the outside. If we compare it to the parent function, we can see that it has in fact been transformed. So the parent function log base 3 of x, you can see that it has been vertically compressed. It's flatter than the parent function, and it's also been shifted down 5 units. You can describe transformations of logarithmic functions by comparing the equation of the transformed function to the parent function. You can also use the values of a, b, h, and k to write equations of transformed functions.